Autophagy is the body's internal housekeeping system, a vital, non-stop recycling process that breaks down damaged cellular parts and clears out metabolic waste. It's what allows cells to adapt, survive, and regenerate, especially under stress. But like any maintenance crew, autophagy has its limits. When overwhelmed by continuous demand and insufficient downtime, it begins to falter. And few patterns stress this system more relentlessly than chronic carbohydrate overnutrition. The abundance of glucose, the constancy of insulin spikes, and the persistent activation of growth pathways push cells toward a state of internal congestion, where damage accumulates faster than it can be cleared. What follows is not just metabolic dysfunction, but accelerated aging at the cellular level. Under normal circumstances, carbohydrate intake isn't harmful. Glucose is, after all, a primary energy source. But the modern environment of ultra-processed foods, frequent eating, sugary beverages, and oversized portions has created a scenario where the body is rarely, if ever, in a fasted or low-insulin state. This constancy suppresses autophagy chronically, especially in tissues like the liver, pancreas, and muscle that are sensitive to insulin. These tissues become storage warehouses that never get cleaned. Damaged mitochondria linger, protein aggregates build up, and endoplasmic reticulum stress intensifies. Cells essentially run on half-functioning machinery, producing energy inefficiently and leaking oxidative byproducts in the process. When glucose floods the system continuously, insulin becomes elevated around the clock. High insulin keeps the mTOR pathway chronically active, signaling cells to grow and store instead of clean and repair. This might sound beneficial in the short term, more growth, more energy, but over time, it leads to cellular hypertrophy without adequate turnover. Autophagy is sidelined, and without it, there's no check on the aging process inside the cell. Organelles wear down. Mitochondria become less efficient. The insulin receptors themselves degrade, contributing to insulin resistance. In many ways, the cell mirrors what happens in the body. Growth without renewal eventually results in dysfunction. This is why chronic high-carb overnutrition doesn't just lead to weight gain. It contributes to metabolic collapse at a much deeper level. Autophagy is essential for maintaining beta cell function in the pancreas, where insulin is produced. When autophagy fails here, the cells become less responsive to glucose, more inflamed, and eventually undergo apoptosis. The result: type 2 diabetes. Similarly, in the liver, autophagy helps process lipid droplets and prevent fat accumulation. Without it, the liver becomes fatty, inflamed, and fibrotic. In the brain, impaired autophagy correlates with reduced synaptic plasticity and increased neurodegeneration, both worsened by chronic hyperinsulinemia. Even skeletal muscle, the primary site for glucose disposal, suffers. Over time, muscle cells filled with damaged mitochondria and insulin receptor debris lose their glucose handling efficiency. The muscle becomes less oxidative and more glycolytic, contributing to fatigue, weakness, and inflammation. It's a silent, systemic failure, where each tissue begins to lose its youthful responsiveness and the whole organism starts to feel the weight of accumulated, unrecycled damage. Ironically, the very abundance that made life easier becomes the source of biological wear. The body is never given a true rest, never signaled to switch gears into renewal mode. Autophagy becomes an afterthought, something that cells wish they could engage, but never get the metabolic space to do so. And unlike other systems that can be repaired externally, autophagy can only be restored from within, by removing the blockades and allowing the natural ebb and flow of metabolic signaling to resume. The good news is that this process is reversible, at least in its early stages. By introducing periods of carbohydrate moderation, fasting, movement, and even low glycemic dietary patterns, autophagy can be reawakened. Cells begin to sense energy scarcity again, which is the trigger for AMPK activation and mTOR suppression, the master switches of autophagy. With even modest shifts, like eliminating constant snacking, reducing refined sugars, or fasting for 12 to 16 hours overnight, the body begins to pivot from storage to repair. And once the cycle resumes, the cleanup can begin. But prevention is more powerful than reversal. Understanding that chronic overnutrition, especially from carbohydrates, has a cellular toll encourages a new perspective, one that sees food not just as energy, but as information. Each meal signals the body either to grow or to renew. Autophagy thrives not in starvation, but in rhythm, periods of plenty balanced with periods of metabolic rest. When that rhythm is lost, the consequences ripple through every system, aging the body from the inside out. Thus, autophagy is more than a trendy concept. It is the guardian of long-term metabolic health. And like any guardian, it must be given space to work. Overfeeding, particularly with fast-adjusting carbs, may offer temporary comfort, but at the cellular level, it slowly clogs the very engines that keep us young, resilient, and alive.